Hi, I'm Adolph Oliver, and this is our review of geometric formulas. Most of these you've seen before, but it's important that you know these for algebra, both elementary and even more so for intermediate, because they show up in a lot of different problems that we bump into, and a lot of everyday applications as well. So, what you'll want to do is make yourself a list of these. This is an example where you just plain have to memorize these things and know them. So let's go over all the different ones that you need to know. Our first stop, we're going to visit the old rectangle. And a rectangle, of course, can be defined by its length and its width, usually L and W, the letters used. Well, there are two main things that we calculate in a rectangle. The perimeter, which is the distance all the way around the outside, and then the area of the rectangle. Let's say, for instance, that our length here is 5 and the width is 3. So I've got L equal to 5 and W equal to 3. Well, to find the area over here, A simply equals the length, which is 5, times the width, which is 3. 5 times 3 equals 15. Now, in most cases, we'd be given units here. So if there were units, you would have to put them in the final answer. Okay, perimeter. 2 times the length plus 2 times the width. If you start at one corner and go around, here's one length, here's a width, here's the second length, and here's a second width. So you can see that you'll get 2 of the L's and 2 of the W's. So you can simply say P equals 2L plus 2W. And of course, in our case here, we're going to have 2 times the length being 5 plus 2 times the width being 3. Well, that's simply going to equal 2 times 5 is 10, plus 2 times 3 is 6, or the total perimeter going all the way around is 16. And again, in general, you'd have some kind of units for this. So remember now, there are two things that you need to keep track of for rectangles, both the perimeter and the area. Okay, our next stop is the square. Okay, and the square is basically a rectangle where the length and width are the same. So we only have to give one side, and it's usually the letter S that's represented, because all 4 sides are the same thing. Well, again, the two things that you need to know, one is the perimeter and the other the area. Let's say that we have a square whose side happens to be 3. Okay, well, what does the area equal? S squared. Now, S squared simply means S times S. So one of the ways you could write this is A equals 3 times 3, which of course equals 9. And of course, if you're familiar with what squareds are, you could have written it this way, the 3 squared, which of course gives you 9 as well. So either way of looking at this, but what you have to do is take side times side. That's the same as length times width. So you can see that it's basically the rectangular formula, only L and W are the same thing. Now, of course, the perimeter as well. And the perimeter, once again, is all the way around. Well, you're going to have 1, 2, 3, 4 sides. And if they're all the same, that's why we can say the perimeter equals 4 times S. In our case here, P equals 4 times. Our side is 3. So 4 times 3, the total perimeter all the way around would be 12 units, inches, feet, whatever it was that we happen to be dealing with here. Okay, so remember now, for the square, you need to know the perimeter, which equals all 4 of the sides, 4S, or the area, which is A equals S squared. Okay, now, somebody that you probably haven't run into quite as much here is the guy known as the parallelogram. Parallelogram, it's like a rectangle. It's been kind of bent one direction here. And the top and the bottom are parallel to each other, and the two sides here, which are kind of tilted, are still parallel to each other. So that's where the name comes from, parallelogram. And what you want to be familiar with here is the area. And the area of a parallelogram is simply A equals base times height, or A equals BH. Well, the base is just this side that the parallelogram is resting on, and the height is any place from the top straight down to the bottom. So all you do to come up with the area here, take the base times the height. Let's say that our base happened to be 5 in this particular problem, and let's say the height happened to be 3. Well, the area then would be the base 5 units times the height 3 units. 5 times 3, it would be 15. Now, by the way, if you had units here, and this was, for instance, 5 inches, okay, and 3 inches, for instance, then what you'd have, of course, is inches times inches, and the units coming out here would be inches squared. Area is always in square units. Okay, well, you may have bumped into the parallelogram before. Here's another one that you may or may not have seen, known as the trapezoid. Now, here's the difference here. The trapezoid, the bottom and the top, are parallel to each other, but the sides can be slanting different directions. That's how it's different from the parallelogram that we just dealt with. And what you want to be familiar with here is how to calculate the area of one of these guys. Well, for the trapezoid, the formula is you turn around and take the average. So here it is, A plus B, the average of the top and the bottom. In effect, what you're doing is you're kind of making a rectangle out of it. That's the effect of this. And of course, you have to divide by, or not divide, but multiply by the height. So here's the formula. A equals 1/2 in parens base plus A plus B, the two sides here, times the H, the height. Well, okay. Let's say in our problem, the A is 2. I'll make a better looking 2. There we go. And the base down here could be 6, let's say. And the height, let's say, happens to be 4. Okay, well, here's how we're going to do it. We're going to say 1/2 times, now, the A is 2 and the B is 6. So 2 plus 6 times the height, which we said was 4 in this case. Okay, well now, in effect, what's happening here is you're taking the average of the top and the bottom. You add these together. Remember, you got to do what's in the parens first. This comes up to give me 8. So if I turn around and copy everything else back down here, the 1/2 times 8 means that we're averaging the top and the bottom. We got these two guys. We added them together. Here it was. And we're dividing by how many we have. So if I take 1/2 times the 8, that'll give me 4. And of course, the 4, which is the height, we end up with a total on this of 16. And if it was in inches here, this would be inches times inches. We'd have inches squared once again. Okay, now, triangles play an important role in a lot of things we do. And again, just like the rectangle and the square, for a triangle you want to know the perimeter and you want to know the area. Well, we bumped into this area formula for triangles a little while ago. A equals 1/2 base times height. Okay, let's go over and define what we've got here. The base is the side that the rectangle is resting on here. And the height, take from the highest point, drop straight down to the base, wherever you hit it, and that's the height. So, let's say in this particular case that the base happens to be 8 here, and let's say the height happens to be 4. Okay, well, the area then is going to equal 1/2 times the base times the height. So I'll put these guys in parens. Here they are. And we said the base is 8. and the height is 4. And these could be like in inches again if we were doing that, or feet or whatever. So when we multiply these guys together, I end up with 4 times 8, which is 32. We still have to divide it by the 2, but notice we have inches times inches, so there's the inches squared. So what's our area on this turn out to be? The area on this, we take 32 divided by 2, ends up, of course, giving us 16 inches squared if these guys happen to be in inches. Now, let's go over and visit the other thing. The perimeter here, okay, of this. Now, perimeter again is just adding all the sides up, and in a general rectangle or a triangle like this, you got 3 sides. We already said our B was 8. Let's say the A is 9. And let's say the H over here happens to be 5. Well, you simply add them all up. The perimeter is going to equal the A value, 9, plus the B value, which is 8, plus the C value, which is 5. So what do we end up with here? 9 and 8 is 17, plus 5 is 22. And if it was in inches, these guys would all be just plain inches, like terms. They're not multiplying each other. So that's why the total here would be the 22 inches going all the way around. Okay, well, let's recoup here. The 2 formulas you want to know for the triangle here. Okay, the perimeter. Perimeter, of course, simply means add up all the sides. You don't really need to remember the formula. Just remember what it means and add up all 3 sides. But, of course, the area, which is 1/2 base times height. That's something that gets used quite a bit. You definitely need to know this for the triangles. Now, let's visit what's known as a right triangle. A right triangle is special in having a 90-degree angle, and I'll emphasize it here. Folks often put a little square box in here, which means that's a 90-degree angle here. And here's one of the things about the right triangle. There is a theorem known as the Pythagorean theorem. This was first worked up by Pythagoras and his school of students about 500 BC. So this is a formula that's been known for, about 2,500 years, been around for a while. And if you've got a triangle that has a 90-degree angle, what is called a right triangle, that means then that this Pythagorean theorem holds, and only for a right triangle. You always take the side C to be the longest side, what's normally called the hypotenuse. The A and the B are the other sides, and they can be either way. This could be A, this could be B, or vice versa. That doesn't matter. The C, though, definitely has to be the long side, which is opposite the 90-degree angle. Well, we'll be using in the course in the future here this Pythagorean theorem. And the idea is this longest side, if you square it, C squared, it equals the sum of the squares of the other 2 sides. So it equals A squared plus B squared. Okay, well, the Pythagorean theorem, again, only holds for triangles that have a 90-degree angle like this. Now, we'll be making use of this in the future, and you'll study triangles a lot more when you get to trigonometry. Basically, trig is the study of triangles, but all of them, not necessarily just the ones that happen to be right triangles here. This is the easy one we can work with here in the algebra. You'll learn all the others when you get to trigonometry. Now, let's jump back for a second to our triangle before. There's one other thing that we should mention, and this holds for all triangles in particular here. Okay, doesn't have to be a right triangle, any triangle. If we number the corners of the triangle here and measure off the number of degrees, let's say this is angle 1, and this is angle 2, and this is angle 3 up here, and I'll circle these guys. These are the 3 angles in the triangle. Here's another relationship that you need to be familiar with, and that is if you add up all of these three angles for any triangle, no matter what shape it is, the angles in a triangle, okay, and there of course are three of them, angles in a triangle, okay, what's going to happen is they always sum up to 180. So if I just use the numbers that I've got here, angle 1 plus angle 2 plus angle 3, the thing you have to remember is that this equals 180 degrees. We'll be using this in some of the problems that we come up with in the future as well. So again, no matter what the shape of the triangle is, it can be a right triangle or any other shape, if you add up all three of the angles, they always add up to 180 degrees. Okay, well now, moving on, let's visit that figure that the Greeks loved, the circle. And of course, the beautiful thing about the circle is it's great for making wheels, so you can, push carts around, and of course we get great mileage out of them in all our cars nowadays. Here's the thing. There is the perimeter of a circle, but circles are special. The perimeter of a circle is known as the circumference. Now, a little bit earlier on, we talked about, when we're talking about formulas, the fact that if you go straight across, you've got a diameter. And what the Greeks found out, of course, was the circumference equals pi times this diameter. But you can also express it in terms of the radius. And here, if you come from the center just up to one side, is what we normally call a radius. And you can rewrite the circumference formula in terms of the radius. Now let's point something out to you here. And that is that a radius is half of the diameter. If you go from the center, here's one radius this way, and you go from the center the other way, there's a radius that way. So the full diameter equals 2 of these radii going both ways. So of course, if we turned around and made use of that, d equals 2r, replace the d here with the 2r, we get c equals pi times 2r. And of course, folks usually put the number in front, so we could say pi c equals 2 times pi r. And that's exactly the formula that was given up here. So, the formula for the circumference of a circle can be expressed either in the diameter, pi times the diameter, or, since you know the diameter equals 2 radii, you can replace the d with the 2r, and of course we like to put the number in front, but you can come up with c equals 2 pi r. Okay, now of course there's still one more thing, coming up with the formula for the area. A equals pi r squared. Now, there are lots of ways to show this to you. The most elegant way, of course, is doing an integral in calculus. That's a long ways ahead in your math upbringing. But there are lots of nice little graphic ways to prove this. But we're just going to give it to you right now. You've probably heard this before. Area of a circle equals pi times the radius squared. So, for instance, let's say the radius of this guy happened to be 3. If r equals 3, let's put it right here, okay, then to find the area here, and I'll put inches again, just to have some units, A equals pi times the r squared, and I'll put the 3 inches in here for the r and square it. Now, if we square this, it's going to be A equals pi times 3 times 3 is 9, and inches times inches, this is where the squared units come from. Now, you still have to plug a value in for pi, and we'll just point out to you now, and you probably bumped into this before, that there are 2 common values that folks use to represent pi. Remember, pi is an irrational number, which as a decimal goes on forever, never terminates, never repeats. But sometimes folks will round it to the hundredths place and use 3.14. That's the value to two places. Or the other thing is you sometimes see folks using the fraction 22 sevenths. 22 over 7 is very close to the same 3.14. So if you want to find out what this total area was, you take this 9 times either one of these guys to come up with the final area, and of course the units would be in inches squared. Well, so far, all of these things that we've talked about here have been basically areas or perimeters, things like that. But now we're going to start talking about volume. Okay. Volume means, for instance, a container that could hold water, for instance. Well, there's just a couple of these here in the elementary algebra that we really need to be familiar with. You'll learn more when you get further on. What if we have a cube? You can think of the sugar cube, although I don't think we see sugar cubes as much nowadays as we used to. But if you have a cube, that implies that all of the sides are the same. So, across the front, along the side, and straight up, they're all the same thing. And we can use that same S again. So what's the volume equal? Well, we take and find the area of the bottom. S times S is S squared. That's the old area formula for just a square. But then you have to multiply by the height. So S times S gives you S squared, multiply by S again, and you got three of them multiplying each other. So that's where we say V equals S cubed. Okay, well, if our side happened to be 2 inches here, then what's the V going to equal? Well, it's going to equal the 2 inches cubed, which, of course, one of the representations, if you want to kind of drag it out here, would be 2 inches times 2 inches times 2 inches. Remember, that's what a power like cube means, how many times you're multiplying this guy. And, of course, what would that give us if we multiplied that all the way out? V equals 2 times 2 is 4 times 2 is 8. But now notice the units. Inches times inches times inches. We've got three of them multiplying each other. So now what you have is cubic inches. This is the classic thing that we have when we measure volumes. The units are in cubic inches. Okay, well, one last guy here to be familiar with, another volume one, is a guy like the cube, but now the sides can be all different. Let's say the front is the length, okay, and then we've got the width going this way and the height going up that way. Well, just like we did with the cube, you multiply the three different sides together. So what the volume equals here is length times width times height. And again, if somebody gave you a value for each one of those, you just plug it into this, multiply them all together. And of course, if it was all in inches, your units would be in inches cubed again. Well, now, here's the thing. You want to know these formulas that we've introduced you to here. You should maybe go back through this little video clip and make yourself a list of all of these. And you've got to practice them and have them memorized, because they're something that show up and you need to know the formulas when you bump into a problem that's dealing with them.